We're talking about linear programming, and there are a lot of terms involved with linear programming, so we'll start with vocabulary, and then we'll examine feasible region, test vertices, find maximums and minimums, and then do some applications. As we look at this drawing at the bottom, this is an example of linear programming where we have two linear inequalities, actually four linear inequalities that create this region in the middle, and our solution for these constraints would end up being somewhere in the shaded region. Most of the time, if there is a max or min, it is located at one of these vertices. So here we have four vertices. Linear programming is graphing a system of linear inequalities to find the solution of a system, solve linear programming problems, and use system of linear inequalities and linear programming to solve real-life problems. So here we have the vocabulary. Linear programming is the process of optimization. And then we have constraints. And constraints are restrictions or limitations on the variables. So in this case, our constraints are these inequalities here. And so, for example, this is a -1, -2, -3. So this would be x is greater than -3. So we wouldn't be able to shade anything less than -3. And then we have some other linear inequalities that end up forming this feasible region in the middle. The feasible region is the set of all possible solutions, and that is just everything that is inside the given constraints. The objective function is a linear function subject to a system of linear constraints. Okay, so here are the linear constraints right here, and something that we should note is the objective function is separate from the feasible region. So this is the feasible region. This is what we can produce from the given constraints, but then we'll take these values and substitute them into a different equation. Then we have two types of regions. We have a bounded region, which is an example that we have here. It is a feasible region with constraints on all sides. So here we can see that this is kind of a funny shaped box, but there's no place where this is not bounded. The other option we have is unbounded, a feasible region with at least one side with no constraints. So here we have a constraint here. We have a constraint here, but then we can see that we can keep going in that direction. And then a real key part of linear programming, not that any of these are not key, but we have the linear programming, the Vertex Principle of linear programming. If a max or min does exist for the objective function, it occurs at one or more of the vertices. So in this case, we would find our feasible region and identify the vertices, which we have identified. That we'd use those coordinates, and then we'd substitute those four coordinates back into our original objective function and see which one fits the solution that we're working